Hi friends, this is Hemadri. I am working as assistant professor in the Department of Mechanical Engineering, RMK College of Engineering and Technology. Today I am going to discuss about isothermal transformation diagram, that is called triple T diagram, time, temperature, transformation diagram. So it will come under heat treatment process. So first we will see the experimental setup of triple T diagram for 0.8 percentage of carbon steel. So first we have to take the steel samples. We have to attach with wire handles, and then here we can fix. And then these steel samples we will keep it in the furnace and then heat up to some 727 degrees centigrade. So once you are heating entire steel samples, it will be converted into austenite structure. So then after converting into austenite, one sample we will keep it here in molten salt bath, that is called incubation bath. So first sample we keep it here for some time, so then we can take second sample, we will keep it here. So once we are keeping one by one, so some of the samples that it will convert from austenite to perlite. So here itself, during this salt bath quenching, it will convert from austenite to perlite, but still some samples it will not convert into perlite. So again we will take one sample, we will keep it in the water quenching. So this is called water tub. So here we will do the quenching. So what are all the samples here? It will convert into perlite. So it will be there in still perlite structure. So the remaining samples, it will be converted into here martensite structure. So how it is converting means, so because of this heating and then we are cooling into different mediums, so the structure, the steel structure, it will be converting from austenite to perlite. Then some of the samples will be in martensite structure. So this is called experimental setup of triple T diagram. So now I told you about this, how it is converting temperature versus time. So once we are taking this austenite, we are heating up to some temperature, it will be in austenite state. Then slowly we are cooling. First it will convert to the perlite structure, and then we are having, still we are cooling up to this water cooling, entirely we will convert into martensite structure. So this is about triple T diagram. So now we can draw the triple T diagram. So here three parameters are involving in this experiment: time, temperature and transformation. So because of this we can call this as a triple T diagram. So here in triple T diagram, so one above this 723 degrees centigrade, entirely it is austenite. Then slowly we are cooling at this temperature, we are keeping into this molten salt bath, it will be converted into perlite structure. So then still we are cooling, we are keeping into water quenching, entirely it will be converted to martensite structure. Still we are going minus also, it will be in martensite. So here we have to know at what temperature the transformation is occurring, what is the time. So that is called starting of transformation and ending of transformation. So this shape also, so this is called starting temperature and this is called ending transformation temperature. So this shape also, it is looking like S or C shape. We can call this as a S curve or C curve. So here during slow cooling we can observe here, so perlite structure it will happen between 700 to 550 degrees. Again still we are reducing the temperature, it will be converted to binite structure. So the structure it is changing. So still we are reducing the temperature around some 210 degrees centigrade. It will martensite it will start, and then slowly it will complete. So entirely it is in martensite structure. So this is called triple T diagram for 0.8 percentage of carbon. So see how 100 percentage binite will occur. So from austenite to at this temperature around 550 to 350 degrees centigrade. So here the austenite will occur. Sorry, binite. So the austenite it will be converted to binite structure. So same thing here they have given this temperature ranges. So here during this experiment we have to identify the various samples we are keeping into molten salt bath. We have to identify at what temperature the transformation is starting, at what temperature the transformation is completed, and what is the time period. So that's why the triple T diagram it is between temperature versus time. So based on this we can draw the points and then we can draw this curve. We have to identify the temperature and what is the structure we have to identify. So this is called about triple T diagram. So this one it will be drawn between temperature versus time. So for 0.8 percentage of carbon we have already seen how austenite it is converting to martensite structure. So still we are reducing, so keep on we are going to minus also, it will be in same martensite structure. So this is about triple T diagram, especially it will be useful for various applications, like after manufacturing the components we have to do this heat treatment process, we have to increase the properties of the material. So from the triple T diagram we can identify what is the starting and ending temperatures, and we can know the microstructural changes. So that's all. Thank you.